The first lesson in our next unit is on something that we used to call Pythagorean theorem. Um, Now, just for fun, I call it the not Pythagorean theorem because they're actually asking us to no longer call it that. This theorem was actually invented many, many years before Pythagoras discovered it, and Pythagoras was the first one able to prove it and to prove why it worked, which is why his name got attached to it. But I think it's also very important to realize that lots of other mathematicians in other cultures and countries also developed a lot of the math that we study today. So for Pythagorean theorem, if we think of this as a recipe, then the ingredients that we need in order to use Pythagorean theorem in our recipe are this right here, which is a right angle or a 90-degree angle. And so every 90-degree angle is called a right angle, okay? And so obviously we need a triangle. And for our triangle, we have two shorter sides or legs, and we have one. If we draw an arrow right through that 90-degree angle box, it will point to the longest side of our right angle triangle, and we call that the hypotenuse. Okay, and so the things that we know about this triangle already are that this angle is 90 degrees. That means that the angle here and the angle here must also add up to 90 because we know that every triangle has a total of 180 degrees in it. We know that the hypotenuse is the longest side of our right angle triangle, and we know we can always find the hypotenuse by drawing an arrow through the 90-degree angle box. When we work with Pythagorean theorem, we are going to label our triangle in a special way, and it makes it easier for us to find out the unknown sides of our triangle. And so the special way that we label it is we call the hypotenuse side side C. And you notice how it's opposite angle C, so angle C is our 90-degree angle. We also have two other angles. We have angle A, and across from it is side A, and you notice that we use a capital letter for the angle and a little letter for the side. And then we have angle B, and across from it is side B, and again, capital for the angle and small letter for the side. And so if we label our triangle this way, the most important thing being that the 90-degree angle is always C, and the longest side is always C, right across from it, or hypotenuse is always C, then the Pythagorean theorem says that if we take the length of A and we square it, and we take the length of B and we square it, that answer we get when we add those two things together is the length of C squared. And so all we would need to do to find C then is to take the square root of C squared. Now that formula is useful, but it's not as useful as it could be as if we could use it to find the other sides of our right angle triangle. If we can only find side C, the longest side, then what happens if we already know that length and we want one of the shorter sides? So all we do is we take the same formula and we switch it around a little bit so that now the formula is equal to one of the shorter sides in our triangle. In this case it's B. It could have also been A. Whichever one we're trying to find, we're going to keep on the left, and then we're going to take the other side and we're going to move that over to the right side of the equation. And when something moves from one side of the equation to another, it changes operations. So instead of being added on this side, it's going to be subtracted on this side. And so our formula when we're looking for one of the other sides of our right angle triangle is B squared equals C squared minus A squared. Or if we're looking for A, we would do A squared equals C squared minus B squared. So a good way to look at it is you subtract the squares of the other sides when you're looking for a short side. You add the squares of the other sides when you're looking for the longest side, the hypotenuse. So here's a couple of fun examples where we can try out our Pythagorean theorem and see how it works. We need to find the length of the hypotenuse, and we already know that that is side C, and then it's going to be the longest side of our triangle. There it is right there. So this is labeled X. We should label it C because our formula uses A, B, and C. And we know that C squared is equal to the other two smaller sides squared and added together. So let's keep going. C squared equals 6 squared is 36, 8 squared is 64. So C squared is going to add up to 100. And we know that side C can't be 100, right? It's way too big. We'd never be able to make a triangle with sides of 6 and 8 and 100. What we haven't done yet is we haven't taken the square root. This is C squared. We just want C. And so if we want C, we need to take the square root of 100. So C is equal to 10. In the other example, we have sides of 24 and 7. And again, the longest side, the hypotenuse of our right angled triangle, is missing. So we're going to label that with C, and it doesn't matter whether the other two sides are A and B or B and A. We're just going to say C squared equals 24 squared plus 7 squared. And then what we're going to do is go ahead and square those. 24 squared is 598, I think. Let me think about that. No, 500 and, oh, I'm way off, 576. And 7 squared is 49. If I add those together, then I'm going to get 625. And so C squared is equal to 625. Now remember, we've got to make that a smaller number. We're going to take the square root of that answer, square root of 625, which turns out to be 25. And so now we know that C is equal to 25 units in length. All right, here's an example where we are trying to find one of the smaller sides. So I'm just going to call this side A. You can call it A or B, just as long as you don't call it C, because C is 21. And so we have a smaller side that we're looking for. That means we're going to subtract the squares of the other two sides. So we're going to take 21 squared minus 9 squared. 21 squared is 441, and 9 squared is 81. And so that's going to leave us with 360. And so A is going to be the square root of 360. And I don't think that works out to an exact square root. It actually works out to 18.97. And so we'll leave it at that because it's not exactly 19. On the other triangle, let's label this side A as well. And we're looking for a short side, which means we're subtracting the squares of the other two sides. Always start with the biggest one or else you'll get a negative. That's going to get you in a lot of trouble if you have a negative answer. So we have 225 minus 144. A squared then is 56, 70, 81. And so A is the square root of 81, and A is 9. Example 3 is just like the other ones, but then there's a little bit of a twist at the end. Let's pick our unknown side and call it A again. Oops, I was going to put A squared on there. I'm not ready for that yet. So if I'm looking for a short side, I'm going to start with the Pythagorean theorem, the one that subtracts the squares of the other sides. I'm going to find that 12 squared is 144 and 7 squared is 49. And so that's going to leave me with an A squared value of 95. So A is going to be the square root of 95, and that means A is going to be 9.7 rounded to 1 decimal place. All right, I'm going to go ahead and write that in here because that's important, because side A was not only our unknown, but side A is also the base of our triangle, and side 7 is the height of our triangle. And the question is asking us to find the area of our triangle. So this was just the first step, being able to identify the length of the base. Now that we want to find the area also, then we need the formula for area of a triangle, which is just base times height for a rectangle, but then we divide it by 2 because a triangle is only half of a rectangle, right? And so we're going to take the base of 9.7 times the height of 7 and divide by 2, and that's going to give us the area of our triangle, and I get 34.11. And so it says to the nearest tenth of a square unit. Tenth means 1 decimal place, so we're going to take that to 34.1, and then we're going to put units squared because they didn't tell us if it was centimeters or inches or meters or anything else. So we just put units squared there, and that takes care of that requirement. And this is what we call an application problem, where they're asking a question about something that might happen in real life where we would need to use the Pythagorean theorem to work something out. So we have a ladder that's 6 meters. The ladder itself has a height of 6 meters. And so if we think about this as a triangle, the slanted side is going to be 6 meters because the ladder is always on a slant against the wall. Let's draw in our other two sides. We're going to have a vertical wall and a horizontal ground, and we're going to have those meet at 90 degrees because good builders will always make sure that the wall is 90 degrees to the ground. The base is 2 meters from the wall, and they want to know how high up the wall does the top of the ladder reach. So that's this distance right here. And we need to round our answer to the nearest tenth of a meter. It's always important to read the question all the way through to the end. So let's call our unknown side A. And we can see that we already have the longest side, the hypotenuse. So this is going to be the form of Pythagorean theorem where we subtract the squares. So we have a squared equals 6 squared minus 2 squared. That's 36 minus 4, and that's 32. So to find a, we're going to take the square root of 32, and the square root of 32 is 5.7 if you round off to the nearest tenth, or the nearest 1 decimal place is what tenth means. And so a is 5.7. We know that we're measuring in meters, and every time we have a word problem, we're required to answer our question in words. So we would say, therefore, we're going to use this little triangle with 3 dots, which stands for therefore in math, and we're going to say the ladder reaches. We're just going to use the same words as the question used. And then we're going to put in our distance that we calculated, 5.7 meters, up the wall. Just exactly the same words that the question used. I think it would be a really good idea on your notes page, in the first box for this unit, for you to write out the Pythagorean theorem finding the hypotenuse, where we're adding the squares of both sides, as well as the Pythagorean theorem where we're subtracting the squares of both sides to find a smaller side. And also remind yourself to always label the 90-degree angle as angle C when you're drawing your triangle. If you try some of these questions on the worksheet in the workbook and check your answers, then we'll be ready to move on to the next topic.